and next we will move to this parallel circuit. Okay, parallel circuit, what it actually telling us, what are the fundamental characteristics of this power parallel circuit is, you can able to do the multiple path dividers. Okay, so that means it is slightly differ from series to parallel. Same example, just take it, guys. You're having the 3 ohms. Okay, you're having a 3 ohm, but you're having the common power. Okay, that means voltage supplier. Okay, for example, it is giving a voltage. Okay, so this voltage is having a 0 to 230 ohm. Okay, now instead of making a series connection, that means all has been in the series, all has been one after one after one after it has been connected in series. But for this, for some change, you have been connected this. For first ohm, you have been given the separate connection. Ohm 2, it is having a separate connection, and ohm 3, it is having a separate connection. So this is how you have been designed the series connection. Okay, now you just check it out. Okay, now you just simply check it out. Okay, now it has been connected in series. Okay, it has been connected. For example, you just consider, okay, this is the series, sorry, it's a parallel circuit. Okay, so for example, you have been made the connection like this. For at the beginning, okay, so this is the voltage. You just check it. This voltage is same for this ohm. The potential difference between same. At the same time, this voltage difference between these two nodes is same, and the voltage difference between these two nodes is same. Because if it is a 230 ohms, yes, the potential difference will be same. Because it's common separate node. Right, here I didn't bring up anything to be add on here. It is only one ohm has been connected here. Okay. Then what I'm going to be do is I'm giving the same amount of potential amount of power I'm trying to give, but I plan to give the current is now going to be start, right? So the current flow will be start. The electrons will be moved and the current flow start. So when I'm giving the some potential, okay, here you can able to see some of the current will be flow this direction. Okay, you just keep my point clear. Some of the current has started to move this direction, and some of the current start to move this direction, and some will be moved to this direction. Okay, so you just see my word, hear my word. Some of the current. That means the current will definitely get varies. Okay, the current will definitely will get varies. Okay, so here you just simply see the thing like when the ohm it is having the multiple appliances, so it requires a more amount of current, right? When the ohm it is having the less amount of things. Okay, so this ohm it is having the less high things. Okay, high electronic appliances they are having electronic appliances. What will be happens? This ohm it is having the low electronic appliances, and this home it is having the medium electronic appliances. So because this low electronic appliances, they didn't have any AC, fridge or TV. Okay, they're just having a only the basic electronic appliance. They're like fan, mixie, and kind of thing. Only they are having mixers or these kind of very basic electronic appliances. Only they are having. Okay, so it might be vary. So how you can easily recognizing this concept? So if this ohm is it is having the high amount of current, so it might be varies. But but if you just think you just simply apply this in circuit. Okay, if it is confusing that, you just simply apply this circuit in the in your circuit. For example, this is your parallel connection you have been given. So this is the parallel connection you have been given. Okay, here you have been apply the somewhat the voltage which is 5 volt. Okay. Now you just consider it is a 330 ohm. It is a 110 ohm. Okay. Another resistor you're going to be adding here, it is a 220 ohm. You have been apply the voltage. The apply voltage, the potential difference between same at this node, same in this node, and same in this node. Okay. But what same? The potential is not going to be changing because whenever it just crossing this one, so the potential will be dropping. Okay. But there is no kind of thing because the potential is same for this line, right? So now you're going to be concentrate on this current because current is started to flow. At the time, it will be taking some current. It will the current will be flow this line and this line and this line. How it is going to be varying if you ask this question? Whenever the resistance it is having a high amount of value, here it is a high resistance. So you can able to see only the small amount of current will be flow through this. So always you are going to be keep this point on your mind. The current will flow. Always the current will choose the path. Okay, it always choose the path low resistance. Okay, low resistivity of the path. Okay, so low resistivity path only the current is always going to be choose. So now you are going to be see this concept. So the amount of current is high here, high this path. So amount of current is medium in this path, and amount of current is very less in this path. Okay, if it is in the first place, not exactly it is going to be choose because it is having the less high resistivity in that path. So it will be choosing always the low resistivity where it is actually the low resistivity. So that path it is actually going to be choose. Okay, it is choosing this path because it is having the less resistivity. More amount of current will be flow through this path. Okay, that is what we have been discussed. Okay, and we will see the key properties and how it is actually working. Okay, if one branch is get failed, others still continue working. Okay, for example, we'll go with this circuit. Okay, I'm just simply creating a new circuit. I'm just simply taking a three resistor parallelly. I'm going to be connected it parallelly. Okay, and I'm going to be give some sorry, I'm going to be give some voltage, which is the value of 12 volt. For example, 12 volt. Okay, this is a 12 volt, and I've started to give this connection. Okay, so simple connection of parallel connection. So what I'm going to be doing is giving a 12 volt. Okay, here it is 1K, 1K, 1K. Same resistance I'm going to be maintaining. Going to be run this one, you can simply see this concept because of I just given the parallel connection. The same, you can able to simply see here, the voltage just remains same. Okay, but how much amount of current is started to produce here? It is 36 milliamp of current is started to produce. But if you just see here, only 12 milliamp of current is flowing this line and 12 milliamp for this line, 12 milliamp in this. So why all the current are same here? It has been dropped. The current has been resist. Okay, only the small amount of current is flowing depends on the resistance we have been used. But why it is same? Because of same resistance we have been maintained here. So this is Ohm's law, right? So now I'm going to be change this 1K to for 330 ohm. Okay. Yeah, 330 ohm. And this for example, I just simply make it as an 220 ohm. Okay, just simply take it as an 220 ohm. Okay, and what will be happens? And finally, this one I made it as a 1K ohm. Okay, you just simply see this one. I'm just running this again. Okay, so the amount of current is it is 103 milliamp of current because the total amount of resistivity you just calculating here is very less. Right, because it is a 330 and a 220 and 1K kilo. Okay, only amount of resistor you can able to see it on here. So at the time, the resistivity is very less. Okay, so that's what it is capable to provide the 103 milliamp of current. Okay, but that 103 milliamp of current, when it started to move, first of all, it just checked this path. So it is having somewhat medium resistivity. So 36.4 milliamp of current is flowing. But it will be choose this, some of the current started to flow this path. Yes, it is having high resistivity. It will be choose this path to flow more current. But in this last one, it is having the more resistivity. So only the less amount of current is flowing this path. Okay, so I can able to simply see this one. So the less amount of current only flowing through this path. Okay. So this is how it is actually going to be calculated. So amount of current is coming through this line. So but it is drop. Okay. And balance amount of current is get move to this place, move to this. Okay. Move to this different path. Okay. And here, if you just check it out, what are the key property is the voltage same across the all branch. If you just see this concept, yeah. So if you want to be find it out because the voltage has not been mentioned here, so I'm going to be add some voltmeter here. Okay, for you to understand this concept. Okay, I simply add on one voltmeter. So what is the whether the same potential is end for this one or not? Okay, so simply I'm just add one voltmeter to find the voltage value at end of the node, which is remains same or not. Okay, I just added on here. Yes, still it's remains same. So when I'm going to be apply the voltmeter on here, it is a 12-volt remains same. Okay, still same voltmeter, but in this region only you can able to see that positive minus it is zero because it is present in the only one direction. So your multiple node, your node is in this is a positive and this is a negative. So this is the two potential in not the single line. Okay, you're going to be understand this concept. Previously, I've been used this node and this node, the voltage remain still remains same. But when I'm going to be apply this voltage, because it's just choosing only one potential in. So at the time, it's still making the zero potential here, zero, zero, zero. So that's what it is, a 0 volt on this place. Okay, I need to be apply on this. In between also, you can able to apply this voltage. Okay, you can able to see this concept. I'm going to be remove one resistance. I'm going to be add this voltmeter and I'm going to be add one resistance. Okay, now I'm going to be make the connection here. Okay, simply I've been made the connection like this. Now I'm going to be started to run this one. Yeah, it still remains same the 12 volt of 12 volt because it's just taking the two end of the potential because all has been connected in the same node. Okay, just taking a potential from this one, potential from this potential. So it just simply taken the example for this water tank. So if you are having a water tank, but the pipe that you are going to be using not only the single through pipe, you're going to be applying the voltage, water. So you are going to be using the different three pipe, but it is taken from the direct water tank. So what will be happen? Same pressure is going to be applied. Okay, so depends on this area, depends on this pipe size, the water flow will be vary. Okay, so water flow is vary, depends on the resistance. So that is the same logic we have been used in the circuits. Okay, okay. So what is the formula for series? When I'm going to be connected the resistance series, what will be the formula is? So R which is equals to R1, R2, 3 of kind of thing. Okay, so we just simply add on this resistance. Okay, you are going to be simply add this resistance and you just keep it on this. You just simply store this one. Okay, because why we are going to add this resistor in series? Okay, so you just think this circuit when I'm going to be connect the resistor in series. R1 is somewhat 330 ohm, R2 somewhat 220 ohm. Okay, this is my resist. Supply I've been given of 5 volt. Okay. So, why we are going to be add this resistor in series means if you just taken this resistance value, total amount of resistance value, which is 330 plus 220 ohm, which is 550 ohm. Okay, this is the common resistance value. So depends on this, you will find it out the total resistance. So you can simply apply into the Ohm's law. Okay. So you have been applied the 5 volt. 5 volt is equals to I into 550 ohm. Okay. Now you just divide this value. You can easily find it out the current value. You can easily find it out the current value. So Depends on this 550 ohm, it is already measured. Okay, I just take an example 550 plus 550, what will be the output? Okay, just cancel out this value. It will be produced 1 by 110. Okay, and it will be the output. It is going to be provided. For example, it is 0.01. Okay, for example, it is a 1 milliamp of current. Okay, so it is already fixed. It depends on the ohms law. We have been calculated 1 milliamp of current only flow through this entire circuit. It is still same in this 330 ohm. It is still same this one 220 ohm. It is still 1 milliamp of current. It is still remain 1 milliamp of current. The potential is only get dropped. Potential is only get dropped. So we have been finding out the constant current value. Okay. If you just taken the another circuit, like you have been given the voltage source. Okay. And here you have been given the 1K ohm. And here you have been given the 20 ohm. Okay. For 200 ohm or 220 ohm. You just simply take an example. If you what you're going to be do that, you just simply add on this resistance. So 1000 plus 220 ohm, it is a 1220 ohm resistance. The total amount is this. Voltage, you know that 5 volt. Okay. So it just simply using this Ohm's law, and you can find it out the constant current. For example, here you have been finding out the constant current is very minute of 0.02 milliamp of current. 0.02 amp of current means same 0.02 amp of current is flowing at the entire circuit. Voltage is only get dropped here. Okay, this is the formula. You can easily understand this. So now we will discuss about this parallel connection. Okay. So for example, if I'm just connected the resistance in parallelly, okay, just see this one. So I'm just connected the resistor in parallelly. Okay. Here I've been given some voltage source. Okay. This is considered as an R1. This is considered as an R2. Okay. You have been given some 5 volt. Okay. Now, what will be the scenario is going to be happen? You're going to be finding out how much current is flowing through this, how much current is flow through this. This is the first thing you're going to be understanding. In the series connection, we don't need to be consider this one because all current is going to be same in this direction. Simply add on all there is. Okay, in the series connection, simply you are going to be add on R1, R2, R3. So you can find it out the total amount of resistance. So depends on that, you will find it out one current value. That current only completely go through this line. Only the voltage will be get drop. Okay, you're going to be always find it out the what is the voltage which is drop in this R1, drop in this R2. Same scenario, you're going to be find it on this one. What is the current which is going to be flow through this R1? Okay, that is considered as an I1. What is the current which is flow through this R2? That is considered as an I2. Okay, that is all cool, but what how you can easily find it out this value is here I'm just taken a Ohm's law. Okay, here we are going to be use the same Ohm's law. That means V is equals to IR. Okay, here voltage is remain same only. Okay, voltage we know that which is same. Current is vary depends on resistor is also going to be what we are actually is going to be. If I want to be find out the resistance value, which is R is equals to V by I. Okay. So in this first scenario, I need to be find it out. Okay, I'm going to be find it out how the current is actually going to be. For example, what is the amount of how much amount of current which is flowing through the R1? Okay, how much amount of current which is flowing through the R1? How much of a amount of current which is flow through this R? If I want to be find like this, what I'm going to be is I need to be find it out the current. What is the current? Okay. So what is the I1 current and what is the I2 current? Okay. So if in this case I need to be find it out the total amount of current for one current for I1. If you want to be find it out, what you're going to be do? So simply you're going to be taking this R1 and this much amount of voltage I'm just providing. That means this is my voltage and V by R. Okay, just simply rewrite this concept. So if I want to be finding out the how much amount of current which is flow through this R1 resistor, you just simply use the what is the I1. That means consider and in this I mean how much of amount of current which is flowing through this R1 resistor you are going to be finding out. If I want to be finding out the I2, that means how much amount of current which is flow through this R2. The constant voltage, the voltage is always constant here. Okay, but what about this R2? Okay, if you want to be find it out like this, you can easily find out the total current. Okay, so this is R1 and R2. I need to be find out the total current. Okay, for that, what I'm going to be do this, I'm going to be simply add this one. Okay, that means I1 plus I2. Okay, this is your consider as a total current. So now V by R1 plus V by R2. Okay. So how it is actually going to be called it as your total current, which is equals to V of 1 by R1 plus R2, 1 by R2. Okay. So this is how it is going to be calculated. 1 by. Okay. So in this concept is cleared. Okay. That is cool, clear. Now, if I want to be find it out the total resistance. Okay, what is the total resistance value? Because a parallel, we can't able to always find it out what is the resistance, what is the resistance of this. We have to find out the what is the total resistance. What we can able to simply use here it is. If you want to be find it out the value, so it just take the same R is equals to V by I. Okay, voltages remain same, but the current is changing. Okay, how the current is changing? It is changing with respect to voltage. Okay, so I just simply taken the voltage divided by P of this value, that is 1 by R1 plus 1 by R2. Okay, the both will get cancelled out, and now 1 by of 1 by R1 plus 1 by R2. Okay, now if you just simply bring it up to this numerator, what will be happen? Okay, so if I'm just do this operation, so it will be go to this, it will be go to this. So your value will be comes like we are going to be add on here, and we are going to be multiply here. Okay. Now it is R2 plus R1, and here it is R1 by R2. Okay. So this is the value you are going to be consider. And when I'm going to be reciprocal here it is the multiplication operation. Okay. And if I just reciprocal it will be considered it as an R1 into R2 divided by R1 plus R2. Okay, so this is how you're going to be finding out the total resistance. Okay, so numerator, so it just having multiplication. It's denominator. When I'm going to bring up to this denominator, it is having a plus. So you're going to be add on the resistance. Okay, so if you're going to be use this operation, you can find it out the total resistance value. Okay, so here you are going to be finding out the first total amount of current. Only with the total amount of current you are actually going to be provided, because if you simply check it out this circuit, this is my total amount of current. Okay, this is the total amount of current I'm going to be provided. Okay, but how much it is going to be dropping, varying this R1 and R2. Okay, what is your total amount of resistance? You're going to be finding out that. Okay, if I want to be find it out for this each one, you can easily check with this I is equals to P by R1. If you can easily find out the one first node of current. If you want to be find out the resistance, you just simply R1 by I. So you can also find it out the what is the resistance which is flow through this. If you want to be find out the total amount of current, you just simply go to this formula. Okay, which has been applied. Okay.